आ जाओ, बंद कर लो। All right, so this is what we had in our last class. Everybody can hear me? Okay. All right, so one example, you are given a graph and you are supposed to compute the shortest distance. Again, there are animations that you can find. So for example, one person wrote this code, and with demonstration of how the algorithm is working. So distance from Bangalore to Delhi. What he coded was Dijkstra and the algorithms that we will see later, right? So Dijkstra was much slower compared to this one, we'll see. So what is the complexity of Dijkstra? In the number of nodes, nodes into, so that can go as bad as n cube, right? All right, so one more thing is 2018 lectures of CS 188 available on YouTube? Right, so then I'll ask you to refer those only, because I'm not sure. I need to check the legal status of using these slides and then uploading it on YouTube. So the world state includes every last detail of the environment. आ जाओ. रिकॉर्ड हो रहा है, बट सब लोग एक एक मेल करना शुरू करो कुर्सियों के लिए. मतलब शुरू के 15 मिनट. सो मेरी शुरू वाली क्लास इसलिए ख़राब होती है बिकॉज यहाँ से लोग चेयर लेके एम्फी थिएटर में जाते हैं. फिर ये वाली क्लास इसलिए ख़राब होती है, वहाँ से लोग वापस लाते हैं. सो द वर्ल्ड स्टेट इंक्लूड्स एवरी लास्ट डिटेल ऑफ द एनवायरमेंट एक्सेप्ट पैकमैन. एवरीथिंग इज एनवायरमेंट to our system because our agent is Pacman. Okay, so every last detail of the environment, as such state keeps only the details needed for planning. A such state keeps only the details need for planning. So what does it mean? So for example, if we are doing just pathing, states are xy, my location basically in this coordinate system. Actions, the Pacman can move north, south, east, west. Successor is update location only. Goal test is this. This is in contrast with if your problem is eat all dots, states, actions, successor and goal test. What is the difference between these two? See, there are two problems. Same environment, same agent, but there are two problems that we are trying to solve. What are they? So first is pathing. What does pathing mean? So you are going from some given state, some given position to some other given position, right? In this case, what is the problem? You are supposed to eat all the dots. So the way you make your search state is different. Right. So the way you define your search state is different. It will depend on which problem you are solving, and that way we'll do things. So if you see, this remains the same, states roughly remain the same, successor update location only, and in this case update. How does this make a difference? See, I am visiting a particular place does not mean that I have eaten a. So, let's say if everything is gone and pellet is just here, then I care only about going there and eating that pellet. Okay. Successor is update location only. Goal test is you just need to go to a particular location. In this case, you need to eat all the pellets. Different problems. ये पूछा मत करो, आ जाया करो. Different problems. Different problems and different ways search state is defined. Search is a very important problem. This will stay with us throughout this course. पूरे कोर्स में अपन सिर्फ सर्च करने वाले हैं. State space sizes. Right. First of all, let us understand what are these numbers. How does this one? How is this 120 coming from? दो मिनट सोच लो, right, for all these numbers. Agent positions 120. How come 120? This will help you because Pacman is here right now. So that means there is a. So this means there is a row here and here as well. I don't know, but Kina. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So 12 into 10, that gives you 120. Next. Food count 30. That is fine. Ghost positions 12. Same reasons because they are just in one column and that has 12 positions. Agent facing north, south, east. So how many states will be there? Tell me how this much. Feel free to talk to your neighbors और एक बार ये कंप्यूट करके बताओ. And my first question will be, why multiply them? Right. So 120 comes because of this. We have that 30. And why 2 to the power 30? Right. So why 2 to the power 30? Either food is present or it is not there. Right. So 2 to the power 30 comes from there. 12 square, 2 ghosts, 4. So what does this number mean? What does it actually give me? Total number of possible combinations of what? So I want an answer in. I want an answer. So you should tell me something about this. Right. So this board, right? All possible configurations is this one. So for example, if this pellet is eaten and Pacman is facing this side, will it be one of these? So no matter, so basically this is the total number of different snapshots this board can have, right? Is this one of them? Yes. So world states is this, but isn't this a super big number, right? So 2 to the power 30 is already more than, so this is more than a trillion already. States for pathing, how come these now? You just need to take care about the total positions for Pac-Man, that's it. What about states eat all dots? You have either eaten a pellet or you have not eaten it, that's it. So this is world state, and if your problem is pathing, this is the number of states, and if your problem is eat all dots, this is the number of states. So world state, it can actually have a lot of other things, but look at the problem that you are solving, okay? Your world state will reduce drastically. Bolo. Agent position 120? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 columns, 12 rows. So 12 into 10, that gives you 120. More questions here. So what are these bigger pellets? What happens if Pac-Man eats them? Right, right. So what is the problem? Eat all dots while keeping the ghost. What does it mean? So there is another constraint, right? So I, for example, so what does this mean, by the way? I mean, simple thing. Right, right.
You have to make sure that you're eating all the dots and there is no moment when the ghosts are not scared.
Exactly. Right? What does this mean again? So, for example, if I go this direction up, I can't be there for more than X number of seconds, because if I stay here, ghosts are not scared. Ghosts will be scared when you eat this power pellet. Okay? So जब भी आप ये power pellet eat कर रहे हो and let's say ये 10 सेकंड में power खत्म कर देता है, so you have to eat a power pellet again in those 10 seconds only. ये बिल्कुल possible है कि आप यहाँ पे हो, I mean let's say ये बिल्कुल possible है कि आप यहाँ पे हो, you are closer to this pellet, but you should leave it and go to this one because that is your condition. Okay, is the problem okay? Problem statement, because right. So then what does the state space have to specify? Exact thing that you had just said. Okay, agent position, boolean dots, power pellet booleans, remaining scared time, right? So these two things are now extra from what we had before. And why do we have these things extra? Because the problem has changed. So what we are saying is world state means what? World state means every possible inclusion of that state space, but it will change depending on the problem that you are solving. Okay, these are two different things, and I might ask a question like this: what is the number of world states and what is the number of states for this particular problem? Ask that again. Right. right? So this makes the problem much more complicated. You will have to sit down and do all this math. Okay? You will have to keep a counter, you will have to keep the distance and so many things, right? State space graphs and search trees. So state space graph, a mathematical representation of a search problem. Nodes are abstracted world configurations, arcs represent successor. The goal test is a set of goal nodes. In a state space graph, each state occurs only once. We can rarely build this full graph in memory, but it's a useful idea. So, barring this, let's talk about these things first. What is state space graph? एक बार इसको छोड़ो, look at here. Let's say you start from here. What is this graph that we are building? एक बार ये सारी theory छोड़ो. You start from here. So your Pac-Man is on the bottom left. There are only two positions it can move to, north and east. So those are the only two arrows coming from here. Now these two arrows are what? These guys. They are basically successor functions. Nodes are world configurations. What is this guy now? We have done all this in previous slides. What is this guy? अच्छा एक बात बताओ. I don't have an arrow from here to here. What does it mean? You cannot go from that state to that particular state जहाँ पे arrow नहीं है, right? So there is no arrow from here to here. What does that mean? Right? So these are directed arcs, right? This is a directed graph, right? Now, so from here I have three arrows because from here I have three arrows because from here Pac-Man can go to north, east and south as well. What about this guy? We have two arrows here. From here you can go to here, from here you can go to here. This is still reversible because there is no eating of pellet is involved. Okay. So we know successor functions now. What do you mean by successor function? I am in a current state, right? Anything that tells me where can I go is my successor function. Okay. So successor function takes input what? Current state. And what is its output? Next possible states. All possible states? Yes. Nodes are world configurations. You have to explain me this now. So for example, how many nodes in this graph? Tell me the number of nodes in this particular graph. No. State space, state world. World configurations. Same as what we did that, 120 into 2 to the power 30 and so on. So, but this is a much smaller number. And you don't have to give me the multiplication. You just have to give me this into this into this. How many positions? 9. Right? $36? See, I would say 9 into 2 to the power 2 to the power 8 and into 4 will certainly be there. What else? And this is giving me the upper bound because there are cases where I might not have into 4. Okay. So what was the last thing? I think this is only there, right? 8 pellets. So what was the final figure? 9 into 2 to the power 8 into 4 into what was the last thing? Okay, ghosts are not there, right? So this is all we have. So many nodes here. अच्छा एक बात बताओ, can a node repeat? Can you have a node multiple times? By repeat I mean, so for example this state, exact this configuration appears somewhere else too. Can you make such a graph where things repeat? Yes, you can. But is that desirable? No. Right? We would like to have a graph with each node as a unique configuration. And why do we want that? Making this is already super difficult and super memory intensive. We don't want to have multiple redundancy in our graph, right? What else? So is this fine? What are all these states? Say that again. You mean this into that? Okay. So again, I can't do this. You have to help me out. Total states 9 into 2 to the power 8, because there are 8 food pellets. So my configuration will be either eaten or not eaten. Okay. Into 4, because my Pac-Man can be in at most 4 directions. But in this case, if you see, there is only one position where I can have all 4 directions available to me. Center, right? So if you want to reduce the number of states from what so the number that we have given is a upper bound, right? You can't have more than this, but you can certainly have lesser than this. And in computer science, we care about lower bounds too, but we want to know the worst case. How bad can it get? Okay. So you have that big a graph. ये number कितना आएगा यार total? 2 to the power 8 is 256. 256 into 9, that gives me close to, let's say 2000. Into 4, that gives me 8000. So roughly 8000 states just for this small configuration. अब you think कि 9216, right? So अब think कि if full configuration is given to me, not just this small one, the state space is huge. And to store this, it will not be just one number like 1 byte. Storing this will be memory intensive again. So in a like final thing, the goal test is a set of goal nodes. What might be goal test in this case? Our goal is to eat all the pellets. So what might be the goal test? No, give me the state. So no food pellet, something like that. But will there be just one configuration like that? No. Tell me, will there be just one configuration like that? How many total configurations can you have in which the board is empty but still they are all distinct? 9 into 4, that is the maximum number, right? Because your Pac-Man can be in different directions. So even though board is all empty, so but give me the exact number, not 9 into 4. So 4 into 2 plus 3 into 2 plus 4. 4 into 2 क्यों? 4 corners, There I have only two things. So 8 plus 4 into 3 because of these sides, right? So that gives me 20 plus 4, that gives me 24 and not 36 if you are exactly counting the total number of possible configuration. In a state space graph, each state occurs only once. So ये चीज अपने दिमाग में एकदम बिठा लो ढंग से. Even if I ask you to draw something very simple, it should not repeat. Okay? Is this idea clear? What are we doing here? Okay? And you being third year students can already tell this is huge, right? Problem changes. We are not talking about Pac-Man anymore. This is our problem. So what are we getting in this? You start from here and this is your goal. So this is your start. This is the goal. What is happening here? So you can give me total number of paths and so on, right? We'll concretize this more. Search trees now. देखो, state space graph ये चीज लिख लो because I have just too many problems with this. बच्चे मिड सेम में ये गलती करके आते हैं. If I ask you state space graph, I'm asking with this thing. I'm asking for this thing, ये जो यहाँ पे बना रखा है, जिसमें आपके nodes क्या होंगे? They will be the elements of world space, world configuration. Okay, that means total possible configurations जो आपके पास हो सकते हैं. Whereas if I am asking you for search tree, ये देख लो यहाँ पे नाम में ही tree है. Tree is a special kind of graph जिसमें there are no cycles, right? So what are we doing here? This is my start state. We have seen this before. वो जो ग्राफ अपन ने देखा था उसमें यही चीज थी. What will be the difference between this tree and that graph? Cycles नहीं होंगी. Okay? All right. Think over why removing cycles is a good idea. So this is done. Next what? But we are not directly removing cycles. We'll see कि in a way they will creep in here too. But not in terms of looking at the graph, but in terms of getting or reaching to the configuration you have already reached. So this is the start state. I can go only for these two configurations from here. What if the tree of plants and their outcomes? A start state is the root node. The children correspond to successors. Nodes show states but correspond to plants that achieve those states. What does this mean? For most problems we can never actually build the whole tree. And why so? Because the number of nodes will still be as many as the number of nodes in the world graph, right? So tell me, where can we have repetitions in this case? We can have some repetitions. Can we? I'm not sure. So let's say, can you reach to the same state from two different paths? Can that happen? Yes. Right? So for example, and the emptier it is, the more is the likelihood that you can reach there from multiple paths. See, if it is full, the chances of repetition will be lesser. But if the emptier it becomes, the chances that you will have repetitions increases. Right? Even direction may remain same.
But the pipeline is facing
Yes, even that may remain the same.
empty, so we can come to that.
Right. Huh. Done? Tell me about this now. So this was our state space graph. I want to build a tree from this. So each node in the search tree is an entire path in the state space graph. We construct both on demand and we construct as little as possible. This will take some time. So I am making search tree. You are at state S. From S I can go to D, E and P. D, E and P. Now expand. So have you seen this kind of thing before? Which algorithm? You have seen this before. I mean, not constructing this, but once you give this, how to navigate this? BFS or DFS. Okay. So in this case, let's say we do it BFS. So you come to D now. Expand D. D will, so from D I can go to B, C and E. What do I do next? I come to E, let's say. From E I can go to H and R. From P I can go to Q, and we keep on building this. Okay, that we can do. Now what is the problem with this search tree? I mean, there is no problem per se, but if you see there is a G node here, and can I see that somewhere else too? Here, right? So that was the thing I was talking about. Things might repeat, but is this repetition in sense of repetition? No. If you see, path is different. So in this case, path taken is S, D, E, R, F, G, and in that case I have S, E, R, F, G. Right? But if this path is taken, what might that mean? If this path is taken, what might that mean? This must be the shortest path, so maybe cost here was just higher. Okay. Okay, so I'll take a pause here. Can everybody make this search tree from that graph? Or any questions here? So we can do that. Then you have to build a search tree for this graph. And don't be surprised if I ask this exact question in the mid-sem. You start from S, so S will be your root node, and from S you have two possibilities. You can go to A and you can go to B and keep on expanding this. Done? How many of you have completed? Okay. No issues faced? Easy? Okay. Any issues? No issues? ऐसा नहीं है यार. Repetition is there. This is an infinite depth tree, right? So how big is the tree? So you have a finite graph, but its search tree is, right? They didn't even care to draw it. So S to A to B, S to A to B. Now from A I can go to G and, so maybe S, क्या था भाई, B and G. From B I can go to A and G. From A I can go to, so this subtree will repeat, and same thing this side. So this is an infinite tree. State space graph is just 4 nodes big, but search tree is infinite. So something is wrong. What is wrong? Right? So okay, they have it. Lots of repeated structure in the search tree. So what do we need to do? How do we do this? We are, and this question I have asked almost in all midterms, right? It doesn't guarantee that I will ask to you as well, but I am just trying to tell you कि इस type के questions will be there. So this is your state space graph. Build a search tree. You are supposed to go from Arad to Bucharest. तो स्टार्ट तो करो भाई. Give me first 2 levels. Huh? I'm not asking you to draw this whole thing. Give me first 2 levels. So you start from, let me see if we have it here. See, just expand those nodes which take me to Bucharest. So maybe 2 or 3 such things will be there. Don't, for example, just discard this path. Okay. What I care about is Arad, Sibiu, Fagaras and Bucharest, and then Arad, Sibiu, RV and Pitești and Bucharest. This given a graph, you should be able to convert it to a state space, a state search tree. So Arad से क्या था भाई successors? Zerin, Sibiu and Timisoara. So Sibiu, Timisoara, Zerin, what they are doing is keep it in the lexicographic order, alphabetic order, Sibiu. Okay. Now expand Sibiu. Sibiu, so you can go to 4 places, Oradea, Arad, Fagaras and RV. Arad, Fagaras, Oradea, RV. Now Timisoara, you can go to Arad and Lugoj. So Arad, Lugoj, from Zerind you can go to Arad and Oradea. This one. Now एक बात बताओ, this is fine. What should I expand now? अब देखो, I don't want to be expanding everything. अपन क्लास में एक पेपर पे ये सब कुछ नहीं कर सकते. So what do I do next? So देखो, CBU will be there in. अच्छा पहले तो आप लोग बताओ which one is the best path? CBU. देखो 140 is common, right? Then 99 80 में 80 comes here, then 211 में 198. So this should be my best path. Am I right? क्या कुछ गड़बड़ की मैंने? Okay. अब इसमें मेरे को बताओ अपने गड़बड़ कहां पे होगी? जब हम ये ड्रॉ करेंगे ट्री, हम गड़बड़ कहां पे करेंगे? एंड दिस इज वेयर मोर देन 50% ऑफ द स्टूडेंट्स डू इट. अभी इसको एक्सपेंड करना शुरू करो. अरड पे आए, नेक्स्ट लेवल पे क्या था? तिमिसोआरा, सिबियू, जेरिन. एवरीबडी सिटिंग हियर, जिनके मार्क्स आएंगे वो भी, जिनके मार्क्स नहीं आएंगे वो भी, दे नो कि दीज टू आर बोगस, वी डोंट नीड टू टेक केयर अबाउट देम. सीबीयू पे आए, सीबीयू पे दो एक्सपेंशंस क्या हैं जो अपने काम के हैं? भाई दिस टेक्स मी बैक, दिस टेक्स मी टू ओरादिया. आई नो इट एट द बैक ऑफ माई माइंड कि दे आर ऑफ नो यूज. सो आरवी एंड फगरास. तो अब सीबीयू पे यू स्टार्ट फ्रॉम अरद, देन आई विल ड्रॉ ओनली. सो लेट्स से राइट नाउ आई एम जस्ट ड्रॉइंग सीबीयू. अब सीबीयू से आई हैव एफ एंड आरवी, एफ एंड आरवी. अब what is the problem next? यार, so A, S and all. Now S say I can go to F and RV. Next is F say I can directly go to my goal state, so which is my basically goal state, and RV say I go to P and then G. What mistake do we do? इस tree search पे आओ, I reach to my goal state earlier, I stop here. I have reached my goal state earlier, so I stop here. What is the bug in this idea? See, if you had all costs equal, in that case, will this be true? Yes. But since costs are not the same, I can have a longer hop path which is actually shorter than a relatively direct path. Okay? All right. So maybe one more minute. Expand out potential plants. Maintain a fringe of partial plants under consideration. Try to expand a few tree nodes as possible. Right? So ये जो यहाँ पे जो इंस्ट्रक्शन है ना अपना कि ट्राई टू एक्सपेंड एज फ्यू ट्री नोड्स एज पॉसिबल, इसमें वी टेंड टू मेक दिस मिस्टेक. जैसे ही अपने गोल स्टेट आई, वी विल डिक्लेयर दिस इज द बेस्ट पाथ. दैट इज समथिंग वी शुड नॉट डू. नाउ दिस इज द डेटा स्ट्रक्चर जो बहुत टाइम लेता है अपन को समझने में. ओके, बट इट इज सिंपली इधर अ क्यू और अ stack or a priority queue. So simple data structure, we'll talk about it. इसको नाम इन्होंने fringe दिया है. Fringe is basically maintain a fringe of partial plants under consideration. ये चीज लिख लो again. Fringe is holding all those nodes जिनको मेरे को अभी expand करना है. Fringe is a data structure that stores all potential nodes that I am going to expand. So then whole thing boils down to how will I take out nodes to expand from this fringe. This fringe will contain a lot of things. How should I expand? ये भी लिख लो चाहो तो. How should I expand? What should be expansion strategy from this fringe such that I do things in a optimal way? Okay. I think that is it for today's class. I mean, this class will meet again at 2. अच्छा, एक स्मॉल क्वेश्चन, what is my fringe when I am just here? देखो एक सेकेंड, my fringe is just this right now, है ना? When I have expanded Arad, my fringe is Sibiu, Timisoara, Zerind. That's it.